Hi, welcome to this Corbettmaths video on triangular numbers. In this video we're going to look at what triangular numbers are and then we'll answer some typical questions on them. So first of all, what are triangular numbers? So we'll start by looking at this visual pattern, and we've got one dot here, so there's one dot, and then we've got three dots and it makes a triangle, 1, 2, 3. And then we've got a bigger triangle, but the base of this triangle, instead of being 2, it's now 3. So we've added on 3 dots beneath. So there's 1, 2, 3, 4, 5, 6 dots there. And then here we've got a bigger triangle, and this time the base is increased from 3 to 4. So we've added on 4 dots beneath, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dots. These numbers are what they call triangular numbers. So 1, 3, 6, 10, and so on. And to find the next triangular number, so the next triangle, there'd be 5 dots on the bottom, so we'd add another 5 dots beneath, so there'd be 10 plus 5, which would be 15 dots. So the next triangular number would be 15. The next one, you would add 6, so that'd be 21, and so on. So these numbers are what they call triangular numbers, and they've got some uses. If we consider a problem called the handshake problem, which we'll look at later in this video, triangular numbers appear in that. And they've also got some other interesting qualities, which we'll look at in this video. So let's have a look at the list of triangular numbers. So the first triangular number is 1, and then if you add 2, you get 3, and if you add 3, you get 6, if you add 4, you get 10, add 5, we've got 15, add 6, 21, add 7, 28, add 8, 36, add 9, 45, so you'd add 10 to get 55, the next one we'd add 11 to get 66, we'd add 12 to get 78, we'd add 13 to get 91, and so on. So these are the triangular numbers. So let's have a look at our first question. So our first question says, find the difference between the second and seventh triangular numbers. So let's list our triangular numbers, the first 7 of them. So 1, and then if we add 2, we get 3. If we add 3, we get 6. If we add 4, we get 10. Add 5, 15. Add 6, 21. And then if you add 7, we get 28. And this is the 1, 2, 3, 4, 5, 6, 7. These are the first 7 triangular numbers. And we've been asked to work out the difference between the second and the 7th triangular number. So to work out the difference between them, we'll take them away. So we'll do 28, take away 3, which is equal to 25. So the difference between the second and 7th triangular numbers is 25. Okay, let's have a look at our next question. So our next question says, Daisy lists some consecutive triangular numbers. So consecutive means one after another. So we've got 210, 231, 253, 276, and so on. So Daisy's carried on her list of triangular numbers, and she's got to these numbers here, 210, 231, 253, and 276. And we've been asked to find the triangular number before 210. So if we look at these triangular numbers, well, to get from 210 to 231, well, Daisy has added 21. And then if she's added 22, she's got the next one. And then if she adds 23, she gets the next one. So if we want to find the triangular number before 210, well, this number, the one we're trying to find, plus 20, because each time we add on one more number, would give us 210. So if we take 210 and take away 20, we will get the triangular number before 210. And 210 take away 20 is 190. So the triangular number before 210 is 190. Okay, next, well, we want to now find the triangular number after 276. So we've added 20, 21, 22, 23. So to find the next one, we would add 24. So if we do 276 plus 24, we'll get the next triangular number after 276. So 276 plus 24, well, that would give us 6 plus 4 is 10, put our 0 down, carry 1. 7 plus 2 is 9, plus 1 is 10, so put our 0 down, carry 1. And 2 plus 1 is 3. So the next triangular number would be 300. And that's it. Okay, so now let's go back and look at our triangular numbers. So here are our first triangular numbers again, so 1, 3, 6, 10, 15, and so on. And one interesting thing with triangular numbers is if you add 2 consecutive triangular numbers, you'll get square numbers. So if we take our first 2 triangular numbers, we've got 1 plus 3, and 1 plus 3 is equal to 4. If we look at our next 2 consecutive numbers, so we've used 1 and 3, now let's use 3 and 6. 3 plus 6 is equal to 9. Then we've got 6 plus 10, well, 6 plus 10 is equal to 16. Our next consecutive number is 10 plus 15, so 10 plus 15 is equal to 25. 15 plus 21 is equal to 36, and so on. And as you can see, 4, 9, 16, 25, 36, they're all square numbers. So if you add 2 consecutive triangular numbers, you will get square numbers. Okay, now another situation where triangular numbers are quite useful is when you consider this problem called the handshake problem. And let's have a look at it now. So there are 5 people in a room. So we've got 5 people in a room. I've called them A, B, C, D, and E. You could call them anything you want, like Alan, Bob, whatever. So everybody shakes hands with each person once. How many handshakes are there in total? So let's consider this. So if we've got these 5 people in the room and person A walks along and shakes this person's hand, that's 1 handshake. Shakes this person's hand, that's 2 handshakes. This person, that's 3. And this person, that's 4. So if person A walked along and shook all 4 people's hands, it'd be 4 handshakes so far. Okay, so let's put person A over here and let's write down there's been 4 handshakes so far. Next, we're going to consider person B. Now they're going to walk along the line and shake everyone's hand. So they're going to shake this person's hand, this person's hand, this person's hand, and walked over here beside person A. And they have shook 3 hands, so 1, 2, 3. So altogether there's been 7 handshakes so far. A shook 4 people's hand, and then B shook 3 people's hand. Next, person C is going to walk along and shake 1, 2 people's hands, and then go over there. So there's been 2 more handshakes. And finally, person D is going to walk along, shake person E's hand, and then walk over there. So that was 1 more handshake, so we'll add 1. And then if we add these up, we'll see how many handshakes there have been altogether. So 4 plus 3 is equal to 7, plus 2 is equal to 9, and plus 1 more is equal to 10. So there were 10 handshakes altogether. And if you look back at our triangular numbers, 10 was a triangular number. And what's interesting, if you consider the number of people that there are, so people, and you look at the number of handshakes, so if there's 2 people, there's 1 handshake. So if there's 3 people, well, if there's 3 people here, A, B, and C, A would shake B and then C, and then B would shake C, and that's everyone shook each other's hand. So it would be 3 handshakes altogether. If there's 4 people, altogether there'd be 6 handshakes, and we've done 5 people is 10 handshakes. And as you can see with the handshakes of 1, 3, 6, and 10, if we look back at our triangular numbers, they are our triangular numbers. So next triangular number is 15, so that means that if there were 6 people in the room, there'd be 15 handshakes. And finally, let's have a look at the general rules. So we've got our triangular numbers, 1, 3, 6, 10, and so on. Now what if we wanted to find the 50th triangular number or the 200th triangular number or something like that? Well, to carry on this pattern would take quite a lot of time and effort. So there is a general rule, and if you're ever asked about this in an exam, the general rule is normally given to you. It's not something that you typically remember off the top of your head, but if you wanted to find the number of dots in a certain pattern in this sequence, you would use this rule. You'd take n and multiply by n plus 1. So in other words, you'd do n multiplied by the next number and then divide by 2. So if we wanted the 50th triangular number, we would do 50 times 51, and we would get that answer and then divide it by 2. Now 50 times 51 is 2,550, and then we would divide by 2, and then if you divide it by 2, we would get that's equal to 1,275. So the 50th triangular number is 1,275. And if we wanted to find maybe the 200th triangular number, you would do 200 times 201 and divide by 2 and so on. And this general rule can be written in a slightly different format. Rather than having divide by 2, you can have a half in front. So it could also look like this, a half n bracket n plus 1. And that's it. So the triangular numbers are the numbers that are found whenever you consider this visual pattern of 1 dot, 3 dots, 6 dots, 10 dots, and so on. Each time we add on another 1 onto the base. So the next pattern would have 5 dots on the bottom, the next one 6 dots, and so on. And to find the next triangular numbers, you start off with 1, you add 2, add 3, add 4, add 5, add 6, and so on. And some interesting facts are, whenever you add consecutive triangular numbers, you will get square numbers. And another interesting fact is there's only 1 cube number that's a triangular number, and that's 1. And there's no other cube numbers in this sequence. And also it can be quite interesting if you consider what the numbers end in, and you'll find that there's certain numbers, the triangular numbers, never end in. And that's it. I hope you found this video useful. There are some practice questions on Corbettmaths. Give those a shot, see how you get on with those. And if you like this video, please like it and feel free to subscribe to the channel. Thanks very much.